Parabola is a special shape that reflects all incoming light to a focus. Right? So all the sunlight coming into that dish reflects to that point and heats up this pot almost as fast as a gas stove when the sun's nice and strong and overhead. Always cook in a black pot because black absorbs the heat. This is a box cooker. You put your... So this is an insulated box, painted black on the inside. It's hot metal in there. A piece of glass on top, which acts as a greenhouse. Right? And then we have a reflector, and you can see that you can adjust the reflector so that the maximum. Can you see that?
Is that a mirror?
This is a mirror. Yep. So you can see as you adjust that, you can adjust it to get the maximum amount of. Are you picking that up?
Yep, so you can see the sun in there.
Yeah, so that you can get the maximum amount of light reflecting into the box. Right. And this is like an oven. So it cooks slowly. It takes a while to heat up like an oven does, and then it will cook. This one will reach a temperature of about 110, 120 degrees, which is plenty to cook slowly. Better designed or bigger ones. In fact, I've got a cardboard one at home that reaches 140 degrees. So, but you can cook slowly.
Place these containers filled with food item inside the box. Now place the solar cooker in direct sunlight. Adjust the position of the plane mirror so that a strong beam of sunlight falls on the glass sheet. The rays coming from the sun pass through the glass sheet and are absorbed by the objects inside the cooker. The glass sheet does not allow the solar energy to flow out in the form of radiant heat. Gradually, more and more heat radiations get trapped and the food gets cooked. The range of temperature that can be attained in this type of cooker is 100 to 140 degrees Celsius.
Do you know that solar panels are not at their best behavior when they become too hot? That is true. While solar PV may be amazing devices that produce electricity and have no moving components, they are a bit sensitive about heat. The hotter they get, the lesser they perform. Or in other words, they like the light but they don't like the heat. In areas where they are the most beneficial, that is the sun belt, they can lose nearly 20 to 25% of their efficiency because of high temperatures, which can reach more than 80 degrees centigrade. So a 100 watt panel would be making only 75 watts at most when it gets really hot. Over the scale of installation and over the lifetime of the panels, which is 30 years, this could mean significant loss of energy. There is something called phase change material or PCM, which you may have come across in household products. The quality of this material is that it can absorb a lot of heat without raising the temperature. PCM can later release the heat when the ambient conditions change or become colder. There are a variety of PCM products available with different temperature ranges. You can select the PCM for the temperature you would like an object to remain. Already in the desert environment, PCMs are used to absorb extra heat released during the day by electronic and electrical machinery. This heat is dissipated later during the night. PCM are ideal match to be used in conjunction with solar panels. Packets of PCM can be placed underneath the panel, which will not allow the heat to build up during the day, and they will release the heat during the night when the panels are not in operation. Plus Ice is an example of PCM product that can be used in conjunction with the solar panel. It should be noted that if the solar panel temperature remains below their rated maximum temperature, then research has shown that their life can be extended from 30 years to 50 years.